All right. So we're going to start off with just right triangle trig. And we're going to start off with SOHCAHTOA, sine, cosine, tangent, understanding ratios. And if you guys can copy those numbers down, the directions say to measure the length, but I figure we'll just go ahead and give those values to you. And then we can talk about reviewing trig ratios for our sine, cosine, tangent, and later on we'll talk about cosecant, secant, and cotangent. Okay, so just spend a minute to copy those numbers down, and I'll scroll down to the others once you have a chance to work on number 1 and A and B. Okay, so just a bit of review. Sine is the ratio for sine in the right triangle is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, your opposite and your adjacent are all dependent on where your angle is. It's relative to your angle, is not a set location. So in this case, we're trying to find the sine, cosine, tangent of our degree measure, 63 degrees. So that means we want to kind of imagine that we are standing in this spot and we're looking out at the rest of the triangle, right? We know that the side that is next to this angle must be the adjacent. The one opposite, the one that's furthest away, the one that's not touching that angle at all is opposite. And then the way we distinguish between adjacent and hypotenuse, because sometimes we do get confused thinking that the hypotenuse is the adjacent. So technically it is adjacent. However, okay. The way we can tell hypotenuse is that it's always going to be opposite the 90-degree angle. So it's going to be the longest side. So the longest side is going to be across the 90-degree angle. Okay. So if we want to find sine, cosine, tangent, sine is opposite over hypotenuse. So our opposite is 8, and our opposite is 8. Our hypotenuse is 9. So 8 over 9. Okay, cosine of 63 degrees. Cosine is adjacent over hypotenuse. So here's my angle. Adjacent is 4. Hypotenuse is 9. So 4 over 9. And finally, tangent is opposite over adjacent. So 8 over 4, we can reduce that to just be 2. Okay, questions so far? We'll explore the other 3 trig functions a little bit later. Right now, we're just doing sine, cosine, tangent. Okay, so you guys can try part B. We have the numbers identified for the length of the triangle. Okay, sine is 7/8, cosine is 3/8, and tangent is 7/3. Okay. All right, let's finish up with C and D. Here are our numbers. We got 6, 14, 13, 10, 5, and 11. Go ahead and fill those out, and then we can identify our sine, cosine, tangents. Okay, let's check our answers. All right, 13/14, 6/14, which can reduce to be 3/7. So I'm going to ask that we do that as well, that later on, if we get our fractional ratio, let's see if we can reduce as well. Right, feel free to use your calculator for now for that. 13/6 for tangent. And then over here for part D, 10/11, 5/11, and 10/5, which is equal to 2. Okay, any questions with first page? We'll go ahead and skip the second page. It's just more of the same. So let's go to page 4. Okay. Anybody still need this? Okay. Okay, just wanted to kind of review. You know, this is all going to feel like review, but I think it's worth our time to do it. Okay, so rationalize. So when we say rationalize, that means we want to try to move or have a different location for that radical in the denominator. We want to shift that radical to the numerator. So the way we do that is we multiply the numerator and denominator by that radical. So multiply by √5. And we're not changing the overall value because we're essentially multiplying by 1, right? √5 over √5 is the same thing as 1. But we are strategically choosing which value we want to involve. We know that √5 and √5 will clean up nicely. So we get 2√5. And then below, we know √5 times √5 is square root of 25. And then square root of 25 can just be reduced down to 5. Okay, any questions there? All right, I want to do another example of these, of this rationalizing, and I think this is something that some students have some questions about. So let me call this 1B. Okay, let's say we had this. Let's say we had 3 over 2 root 7. Okay. We also need to rationalize. We can also rationalize this fraction. But what do you think we're going to multiply the numerator and denominator by?
37.
Just the root 7. Okay. Why not 2 root 7?
You can't multiply that by 3.
Well, actually, I think, you know what, we could multiply by 2 root 7 numerator and denominator. It'll just go away. But what's the only part that we have to adjust? Yes, it's just that root 7, right? So basically, the idea is that the 2 is okay. Okay, the 2 is not the issue here. The 2 will just kind of stay where it is. We just have to multiply by root 7. Okay. But if you multiply by 2 root 7, you'll still get the same answer. The 2 will just end up canceling out. So when I do this, when I multiply across, I get 3 root 7. And the bottom here, I get 2 times, now root 7 times root 7 will become 7. 7 times 2 is 14. Okay, so we're going to see some of these, some examples of this later on where we only have to multiply by a portion of the denominator, not the entire value. Okay, so I just want to kind of go over that. Let's look at number 2. If I want to solve for x, maybe you have a different way of doing it, which is fine. You can multiply or divide by that 3 to basically want to get that x by itself. Visually, I think it's easier if I just think in terms of, well, I just have basically a fraction equal to a fraction. What if I just do cross product? That's a quick way to get rid of my denominator, and I just have a clean way of solving for x. So, but if you have a different way of doing this, that's fine as well, as long as it's algebraically correct. I can think of that 12 as 12 over 1, and I can think of it as, well, I'm just going to pair the diagonals together. Then I have 1 times x equals 12 times 3. So when I do this, I already have x by itself. So really just x equals 12 times 3, x equals 36. Okay, same idea. Second expression, second equation here. 20 equals 5 over x. I'm going to treat that 20 as its own fraction. I can always put a whole number in the numerator and then put a 1 in the denominator. I'm not changing anything at all, just making it matching my form to see where my diagonals are going to be. So I'm going to pair the diagonals together. So here I get 20 times x equals 5 times 1. So it doesn't quite get x by itself, but it does get rid of the denominator, which typically, you know, it's just easier without dealing with the denominator, right? We can just make it an equation that's a lot easier to solve visually. Just divide both sides by 20, and then we can solve for x. Okay, 5 over 20 reduces to be 1/4. Any questions so far? All right, how do we solve for x? X plus 7 equals 19. That's easy. Subtract 7 from both sides. Second one here, x squared equals 30. Well, the x is already by itself, but we want to kind of get that x squared down to x. So the way that we can get rid of that squared is we can take the square root of both sides. Now, technically speaking, okay, whenever you take the square root of both sides of an equation, there's going to be two solutions that pop up. There's going to be a plus and negative version of that answer. So we get it down to x equals plus or minus square root of 30. 30 doesn't break down anymore. There's no perfect squares inside of 30. We can think of 30 as 5 times 6, but neither have any perfect square hidden inside. So we'll say x equals plus or minus square root of 30. Now, this is the correct way of solving for x, understanding that anytime you have to involve an equation and square roots, there's always a plus or minus. However, because we're going to be dealing with physical lengths of a triangle for now, we're really just going to ignore the negative of it. Algebraically, it's correct, but for our purposes, if we're dealing with a physical length of a triangle, the negative is not going to, we'll just ignore that negative, right? Okay, so I'm just going to make that distinction. Okay, bottom of the page here. When we're dealing with adjacent and opposite, just understand that adjacent and opposite are not set positions on a triangle. It really depends on where your frame of reference is, right? So if I'm standing in this corner, then adjacent is going to be this this leg of the triangle below, and the opposite is going to be this vertical part of the triangle. Okay. But if my angle is over here, if I'm standing in this location, then my adjacent to this angle is going to be this side, and the opposite is now going to be this horizontal length, right? So, you know, it really just depends on where the angle is. Where are you looking at the, where are you standing to look at the rest of the triangle? So just understand that opposite and adjacent is really depending on where your starting point is and your frame of reference. Okay. All right, next page. Okay, so we're going to find the sine, the cosine, and tangent of angle A. We're going to find the trig ratios. But here we got to do a little bit more, something a little bit more here, because we are only given two sides of a right triangle. I mean, we can find tangent, but we'll still be missing sine and cosine. So what could we use to help us find that missing side of this triangle? Yeah, Pythagorean theorem. Okay. So yeah, so the angles inside a triangle, we know that they add up to 180 as across from 90-degree angle. We're dealing with a hypotenuse, but if we're dealing with a missing side length of a right triangle, we'll rely on Pythagorean theorem. So Pythagorean theorem here, we can think of it as a squared plus b squared equals c squared. Okay, we can use our calculator to find that c value. So as a reminder, make sure that you're bringing your calculators every day. We're going to be using them. Okay. I'll send out a remind this afternoon for you to bring one in case you forget. Okay, in case you forgot today. Okay, so I'm going to choose my doesn't matter which value is my a and b. These will be my legs, and then the side length on the other side will be the hypotenuse. So in this case, I'm looking for the hypotenuse. Okay, 25 plus 144. Take the square roots. Technically, we should be getting a plus or minus, but because we're only dealing with the sides of a right triangle, we're only going to hold on to that positive value. Yes?
So c squared is always the
Good. C squared is always hypotenuse. However, we're going to be dealing with a lot of these problems solving for the hypotenuse, but not just, don't assume that just because you see a missing side of the triangle, that the missing side is always the hypotenuse, right? It could be the leg of the triangle, which means we may have to be either solving for A or B and not always C. But we're starting with some easier problems here, so we're going to be looking for the missing side will be hypotenuse to begin with, but we're going to see some shift a little bit later on. Okay, we're going to find sine of A, cosine, and tangent. All right, so we are standing here, looking out at the rest of the triangle. Okay. Any questions here? Okay, so using number 1 as your model, see if you can try number 2. Same steps. Pythagorean theorem helps you find that missing side, and then find ratios for sine, cosine, and tangent. Okay, what you guys get for the missing side? 25. 25, okay, good. Okay, questions? Okay, so now moving on to the middle of the page. We want to find 6 trig ratios for angle A, but now we're dealing with 6 trig functions, so just want to kind of talk about how the other ones, cosecant, secant, and cotangent, are just the reciprocals of the corresponding trig functions. So if I flip sine, numerator and denominator, I get the ratio for cosecant. If I flip cosine around, instead of adjacent over hypotenuse, it's hypotenuse over adjacent, that will be secant. And then if I flip tangent around, I get cotangent. Okay, I have it up here on the board as well. Okay, so try number 1. It says find all 6 trig ratios for angle A. Angle A is where theta is. Okay, so I guess that's not very clear there, but angle A is where theta is. Yeah.
So the SEC
Secant.
is the same as cot.
Oh, sorry. Hypotenuse over adjacent. My bad. Let me change that. Okay. All right. Try number 1. angle A is right here. Okay. Again, it's nice that finding that missing side is pretty straightforward. We're looking for hypotenuse again. A squared plus b squared equals c squared. What did you guys get for the hypotenuse? 17. Okay, good. Okay, once you check your answer for number 1, go to number 2. All right. What's different about number 2 that we have to be careful about? Okay. We are not looking for the hypotenuse. So we're looking for either the A or the B value. So we're still using the same Pythagorean theorem, but the variable that we're solving for is going to be a different location. So you can call it any variable you want. I'm going to just call it x. Okay. You're gonna be left with a radical, and when you create your trig ratios, you may end up with a radical in the denominator. If that's the case, we need to rationalize it like how we did with the previous practice problem. Okay, so when you guys catch up, I will go through each step of the problem. Okay, so sine and cosine are pretty straightforward. After we create our ratios there's nothing to worry about with the denominator. But that tangent, we can do a little bit of cleanup, right? So that radical, I want to rationalize that. We also want to find cosecant, secant, and cotangent.
On tangent, can you just leave it like 2 over rather than
Oh, yeah. I cleaned it up here.
can you just leave it before simplifying it down? Or will you like mark points off if you don't simplify it?
Oh, you mean
If I just leave it as like 2, yeah, right there.
this one? I will ask you to rationalize it.
Okay.
So if I ask you to rationalize it, then for full credit, then you will need to go through that additional step. Yeah. Okay, so for tangents, I mean, I can flip either of these, but I'm going to go and try to figure out the faster way, right? If I flip this, I'm going to end up with a radical in the denominator. But if I flip this, then it's a lot cleaner, right? It's just square root of 21 over 2, and I can just leave it as my answer. If I flip this, I have to go further and clean up that denominator. So sometimes I want to kind of pick the easier path to my answer without having to do as much work. Okay, any questions here? Let me highlight the final answers here. There's a lot of numbers here, so. Okay. All right, so let's look at this final example before you guys can start on your classwork/homework. Okay, so here I have it says given cotangent of theta equals 13 over 9, find the other 5 trig ratios from theta. So this one just requires one additional step. We have to build a triangle and populate the missing sides, and then we'll be able to get it to look like one of these triangles. Okay, but let's do this. Cotangent equals 13 over 9. We're going to build our triangle. We're going to build our triangle in the first quadrant. Now you're going to always, whenever you build your triangle from your coordinate plane, I mean, sometimes later on we're going to be talking about unit circle and things like that. So just as a reminder, whenever you may be drawing triangles across different quadrants, but always involve the x-axis when you build your triangle. Okay, never involve the y-axis. If you involve the y-axis in building your triangle, it's going to be all off. Okay, so always involve your horizontal x-axis as part of your triangle side length. Okay, so here is my triangle. My theta is always the angle closest to the origin. Okay, so we're always going to have to, yeah. Okay, so this will be a good thing to kind of build off of for later on as well. Okay, so here's our triangle. Cotangent of theta is 13 over 9. Okay, so where does 13 and where does 9 go? Okay, opposite. I'm sorry, 13 is what? Bottom. Okay, yeah, adjacent over opposite. Okay, so these problems require that additional step. We got to build that triangle. We got to know where to put the side lengths, and then it becomes familiar, right? Okay, so see if you guys can continue with this problem. You have your missing side, which is the hypotenuse. Pythagorean theorem will get you to that side, and then find all 6 trig ratios. And if there's any radical in the denominator, that we're cleaning them up as well. So 13 squared plus 9 squared gives me 250. 250 I can break down into 25 and 10. 25 is a perfect square. I can pull the 5 out. Okay, so now I can just find my 6 or my other 5 trig ratios based off of those side lengths. Okay, so in a minute I will show the answers so you can check. So when you're done with this, go to the next page, and page 6 is your classwork homework. So I think you guys should be able to get through the majority of it, and this will be your first homework assignment that I will check first thing tomorrow in class. But I think 15 minutes remaining, I think you guys can get probably most, if not all of it done. Okay, we'll go ahead and finish this first. In a minute, I will put up the answers for you to check. So if you're done with this, go ahead and start on page 6, and then you can get your homework done. All right, so 2 things that I want to make sure that you guys are careful as you are creating your trig ratios. 1, make sure that you're reducing your fractions at the end. 2nd, that you are rationalizing your denominator radical. Okay. So here, go ahead and check your answer there. Go ahead and start your work on page 6, and I want to just walk around and see how you guys are doing, whether you're comfortable with this and whether you need support. Yes, so I'll send you guys a link to my website. I just put the key of my website so you can check your answer at all. No, I think you can do a lot of this without. Let's go ahead and start with fine. Yeah, that's the so sign up for that. Just maybe this little AI. Yeah. I'll make sure it's that. Right, we're not. We'll do that tomorrow. Right now, we're just. Right. Yeah, right now we're worried about the ratio. Sine and theta. Good, good, good. And now we just put them.
Oh, you just.
Is that cosecant right here? Oh, cosecant here.
Oh. Are you using what?
Yeah.
I'm still right about that.
Yeah, you're right. You're right. I got it.
Did you go on the other ones?
Yeah, you got it. Just reduce it.
You just reduced it, you have 7. I'm gonna redo this.
Okay.
Reduce that one.
Okay, let me just show number one, just make sure that you guys are on the right track. But I will send you the link this afternoon for my website. But you can also just go to the website. Under today's date, you're going to see updated homework key, page 6, and click on that, and you'll see you can check your answers there. So this is what I was talking about. When you have your trig ratio, look and make sure that you can reduce the fraction if possible. So for sine, I can reduce the fraction. And if I end up with a radical in the denominator, I only need to multiply the top bottom by that radical portion. If there's a number without the radical in the denominator, leave that alone. We don't have to worry about multiplying by that number. However, make sure that you don't forget about that number. So I multiply by root 2. Root 2 times root 2 is 2, but don't forget about that 4. 4 times 2 equals 8. Different one, yes. Yeah, so build a triangle. Yeah. Okay. Anybody have any issues with number 1?
Yeah. Oh, the 29.
If possible, yeah. So 8 and the 14 can reduce. So that would be 4. Yeah, so the root 2 stays and the 14. Yes. Yes, please use 8 over 14 that reduces and the root 2 is just not involved. Yeah, so this would be, yeah, but you know what I would do? I would rationalize the denominator first. See You don't want that square root of number. So the first thing we're going to do is multiply polynomial square root. Because we don't want that radical. After I clean that up, then I can decide. This can reduce to.
Good afternoon, Milton Eagles. The following are the bus change announcements. Please listen carefully. Students who ride bus 4086 will now ride bus 4070. Students who ride bus 4134 will now ride bus 4889. Have a great afternoon, Eagles.
Mm-hmm. Yes, it's 3 over. 3 is 3 over 1. So 3 over 1 and then 0. Oh, okay, I got signed. Yeah, that's why. So you're using the wrong one. Okay, so tonight, if you haven't finished your assignment, go ahead and finish it tonight. Hopefully, you guys got most of it done. I'll send you guys a reminder this afternoon. The reminder will have a reminder for your calculator and also a link to my website, which will have a PDF file which has all the problems worked out. I will check your homework first thing in class, and that'll be our first homework assignment. Okay, just page 6. Hey, if there's not enough room on the worksheet at any moment in time, feel free to use a separate sheet of paper to do your work. I'm not going to pick anything up, so whatever will allow you to have room to work, feel free to do that. Sometimes the packet doesn't have as much room as you would like, so make necessary adjustments if you need it.
Thank you.
All right, thank you.
Wait, Gia, are you in bed as well? I don't know how to. So then, like on the website, it says that meeting. But like you did like something else.
Look for your bench in the